Okay, welcome back. Can everybody find this page here? The polynomial function can be described by its degree. So get ready to highlight a few things in your notebooks. Even degree polynomial functions and odd degree polynomial functions. Here's a linear function. It has an exponent of 1. If the leading coefficient is a positive 1, which we know of as the slope 1x, slope 1, that linear function must go up to the right. If the lead coefficient is negative, a negative 1 in front of x, we know that that's a negative slope. It goes down to the right. And a lot of these other polynomial functions have similar characteristics. Okay, let's look at the quadratic next. A quadratic function, if its lead coefficient is positive, we think of that as a parabola that opens up. If the lead coefficient is negative, it opens down. Next, those are degree of, let me go back there for a second. That's a degree of 1 and a degree of 2. Remember that degree is another word for the exponent. Exponent 1, exponent 2. Number 3, degree of 3 means the highest exponent is a 3. So here we go. The lead coefficient is a positive 1. It falls down to the left and goes up to the right. And once again, notice that there are two critical points. There's one here and one here. I know it's a little tough to see for this one, but you have a maximum hill there and a valley here. And for a negative lead coefficient, it goes up to the left and down to the right. Right here. There's a valley, goes up left, and a hill goes down right. Quartics, highest power is a power of 4. Looks like a tooth. If it's positive, it opens up. If it's negative, it opens down. Notice for this one, power of 4 has one, I got the wrong pen there, has a minimum there, a valley, a hill, and another valley. And this one opens down. Okay, so that's an even degree polynomial. Power of 4 degree. Next one, quintic, power of 5. Let's look here for a second. I'm going to grab my marker. This one has a lead coefficient of a positive 1. Means it falls to the left. We have 1, 2, 3, 4 critical points, suggesting a power of 5. Falls left, goes up right. Lead coefficient is negative, power 5. It goes up left, down right. This negative lead coefficient, power of 5, is very difficult to see 4 critical points. And that's because of the way it's graphed, okay? Most of them will have 4 critical points. The odd one will have less than that, but we can still focus on those characteristics for most of the powers of 5. So at the bottom here it says, the end behavior of the graph refers to the behavior of the graph as absolute value of x becomes large. For positive values of x, as x becomes large, we say x approaches infinity. X approaches infinity is written with this notation. X goes to infinity. And the same can be said for negative values. We'll talk about that more in this lesson as it continues.